This is a chain rule application problem. A sum of $1,000 is deposited in an account with interest compounded monthly at a rate of R% per year. At the end of 5 years, the amount in the account is given by the equation below, which is A of R equals 1,000 times 1 plus R over 1,200 to the 60th power. Find the rate of change of A with respect to R when the rate is 4%. So what we want to do, I'm going to rewrite our equation. And we're trying to find the rate of change of A with respect to R. So that means we want to find dA dt, or dA dr. And we want to find that when the rate is 4%. So at R equals 4. But first we need to find this. We need to find dA dr. We have kind of a complicated equation here with an outer piece and an inner piece. So this is when we want to use the chain rule. And we're going to use the chain rule where we take this piece in parentheses and let that piece be u. So I'm going to say that u is equal to 1 plus R over 1,200. And then when we think about A, the equation A, instead of writing this longer equation, we're going to write A equals 1,000 multiplied by U raised to the 60th power. And then when we find dA dr, well, now we have an equation in terms of U, so dA dr is going to be equal to two different pieces. First, dA du. That means this equation differentiated with respect to u, and then multiplied by du dr. So that's going to be this equation differentiated with respect to the variable r. So first let's find dA du in this equation. That would be using the power rule, so take the 60 and bring it in front. 60 times 1,000 u, and then we subtract 1 from the power, so 60 minus 1 is 59. And this we can rewrite it as 60,000 u to the 59. So that's our dA du. And now we also want to find du dr. So du dr is just related to this u equation. We take the derivative of 1, which is 0, so I'm not going to write that, and then the derivative of r over 1,200. We think of that as r is a linear variable and 1 over 1,200 is a constant. So the derivative there would be just 1 over 1,200. And then we can plug in those two values for dA dr. And we get that dA dr is equal to dA du, which was this equation, 60,000 u to the 59, multiplied by du dr, which is 1 over 1,200. And we can simplify this a little bit. We can do 60,000 times 1 over 1200, and that's going to be 50. And then u to the 59. And now at this last step, we do want our equation written back in terms of r, so we're going to substitute back in for u. U was 1 plus r over 1200, so we're going to write this equation as 50 times 1 plus r over 1200 raised to the 59th power, just replacing the u. So this is our equation for dA dr. But now we want that equation evaluated at a certain point. So recall what we're trying to find. We want to find dA dr evaluated at r equals 4. And that really just means plugging in 4 for r into this equation. So that would be, we're going to write that as dA dr with a long bar to show we're evaluating it at r equals 4. That's going to be equal to 50 times 1 plus 4 over 1200 to the 59th power. Calculating this, we get 60.85. We're going to round to 2 decimal places because we're talking about an amount of money. So this value for dA dr, the units for that are the units for the amount, which are dollars, divided by the units for r, which are percentage points. So our answer is $60.85 per percentage point.